Hey, welcome in. Mr. Jorgens here. We're going to be covering section 6.6 on sequences today. We're going to be covering the different types of sequences that you'll need to know about for algebra. So make sure you stay tuned and be ready to answer the questions as you go. So sequences are all about patterns, and we have a couple of main types of sequences that we're going to be looking at today. And the first one we're going to look at is called an arithmetic sequence. And sequences are all patterns and numbers. An arithmetic sequence in particular is a pattern or sequence of numbers where the next number can be found by adding what's called a common difference. So an example of a few different arithmetic sequences would be, my first example of an arithmetic sequence would be something like 2, 5, 8, 11, and continuing on. Now, the reason why this would be an arithmetic sequence is because I can find the next number by adding 3. Right? And so what I would call that is I would say that 3 is my common difference, right? We usually use the letter D to denote a common difference. So I would know it's arithmetic because I can find the next one by adding. And 3 would be my common difference. So if I was asked to find the next terms, I would continue adding 3. So 3 more than 11 is 14. And 3 more than 14 is 17. 3 more than 17 is 20. And I can continue that pattern for as long as I was asked to, right? Another example of an arithmetic sequence would be something like this: 20, 15, 10, 5, and so on. Now, at first glance, you might think this is not an arithmetic sequence because I'm not finding the next number by adding, I'm finding the next number by subtracting. We just need to remember that adding and subtracting are strongly related, right? But instead of finding the next number by adding 3, I'm really adding by -5, right? Adding by -5 is same as subtracting by 5. So really, I can kind of think of this as adding or subtracting a common difference. But in this case, I'm going to think of the common difference as -5. And on paper, it would be as adding by -5, or we can think of it as subtracting by 5. So if I think of my next numbers, it would be 0 and -5, -10, and so on. I can carry that pattern out as long as I was asked to. All right, so we're going to take a look at one more arithmetic sequence here. This one you're going to try. This one's going to be 7, 16, 25, 34, and so on. What you're going to do is try to find just that next number. So after 34, what's the number that's going to come next in this arithmetic sequence? Determine that number and enter your answer when you're ready. So hopefully you realize we're going to be adding by 9. So if I continue to add by 9, after 34, my next number that comes would be 43. So that would be my next number. I could continue on with 52, 61, and so on, but hopefully you selected 43 there. That's kind of how arithmetic sequences work. I'm looking at just selecting that next number in the pattern. Our next type of sequence is a geometric sequence. And a geometric sequence can be found by, or defined by, saying a pattern of numbers where the next number can be found by multiplying or dividing what we call a common ratio. And again, really on paper, that's just multiplying, but dividing and multiplying are related here. Multiplying by a fraction is the same as dividing. All right, so we're going to look at a couple examples of this one to kind of get you ready. My first one is going to be the pattern 1, 2, 4, 8, 16, and so on. Now, the reason I'm going to know this is a geometric sequence is because I can find the next number by multiplying by 2. That's like the key to the pattern, is I can get from 1 to 2 by multiplying by 2. I can get from 2 to 4 by multiplying by 2. 4 to 8 is times 2. 8 to 16 is times 2. So if I wanted to keep going in the pattern, I would continue multiplying by 2. So 32, and then 64, 128, and so on. You should realize that with these geometric sequences, they can increase a lot faster than the arithmetic sequences where we're going by addition, right? Now, a really big phrase is that common ratio. That's going to be something we're looking at a lot here in this section. In this one, our common ratio, we would say R for our common ratio is 2. And that's kind of a big one. We're going to say R is 2 because 2 is that multiplier that we're using to get to the next number. All right, let's take a look at another one here. Example 2. So we're going to be looking at the pattern 81, negative 27, 9, negative 3, and so on. Now this one's going to be a little different for two reasons. One, the numbers are shrinking, so we're going to be tempted to say divide. And the second reason is that we're kind of switching between positives and negatives here, so we're going to have to know what to do about that as well. Now, we can think of it as dividing by 3, right? I can know that 9 divided by 3 makes 3, 27 divided by 3 makes 9, 81 divided by 3 makes 27. But I'm going to have to divide by a negative because 81 divided by negative 3 makes negative 27. Negative 27 divided by negative 3 is going to make positive 9 because a negative divided by a negative makes a positive. And positive 9 divided by negative 3 is going to make negative 3. So negative 3 division is the number that's going to make this pattern go. The problem is when we write our common ratio, I'm going to want to write this as what it's multiplying by. And so I have to know that dividing by negative 3 is the same as multiplying by negative 1/3. And so in this case, I'm going to think of it as multiplying by negative 1/3 because that's going to help me to write my common ratio. That's going to help me to find that next number. Again, when I try to find my next number, I'm probably going to think of it as dividing by negative 3. And when I divide negative 3 divided by negative 3, I'm going to get 1. And when I divide 1 by negative 3, I'm going to get negative 1/3. And when I divide negative 1/3 by negative 3, I'm going to get positive 1/9. And so on, right? But the reason why I'm writing this as negative 1/3 is I'm going to list my common ratio as negative 1/3 on this one. That's why. All right, last example. You're going to help me out on this one. Example 3. 3, 12, 48, 192, and so on. It's a geometric sequence. I can find the next number by multiplying. What I want you to figure out is not the next number in this pattern. I want you to tell me what R is. And R would be the number that we'd multiply to get to the next number in that pattern. So go ahead and figure out what my common ratio or R is and enter your answer when you're ready. Yeah, it'd be 4, right? Because 3 times 4 makes 12. 12 times 4 makes 48. 48 times 4 is 192, and so on. All right, so a big question we're going to see when we get to the homework is this sequence arithmetic, geometric, or neither? So we should be able to try these out again. Arithmetic is going to be where you find the next one by adding. Geometric is when you're going to find the next number by multiplying. And neither would be some other type of pattern where the next number can't be found either by adding or multiplying, but some other type of pattern. All right? So the first sequence we're going to look at is if we have the pattern 12, 10, 8, 6, 4, and so on. So would that pattern be arithmetic, meaning the next number can be found by adding or subtracting, geometric, meaning that you can find the next number by multiplying or dividing, or would it be neither and some other type of pattern? Make your determination and enter your answer when you're ready. Yeah, so I can subtract 2 to get to the next number here, right? Meaning my next number is going to be 2 and then 0 and then negative 2. Since I can get the next number by subtracting, it is arithmetic with a common difference of negative 2. All right, let's try another one. So this one we're going to do is 1, 1, 2, 3, 5, 8, 13, and so on. This is a really famous sequence. It's called the Fibonacci sequence. Would this sequence be arithmetic, geometric, or neither? Go ahead and make your determination and enter your answer when you're ready. Yeah, so this is an interesting one. It's going to be neither. So hopefully we saw that. Now, the way this sequence works is you actually add like 1 and 1, and that's going to make 2. And then you add, which is the next number, right? And then you add 1 and 2, and that's going to make 3. And you add 2 and 3, and that's going to make 5. And you add 3 and 5, and that's going to make 8. Add 5 and 8, and that's going to make 13. So it's kind of like a special type of sequence. If I wanted to find the next number, I'd add 8 and 13, which would make 21. And 13 and 21 then makes 34. So it is a pattern, but it doesn't work arithmetic or geometric like we were doing today, right? There's no common difference. There's no common ratio. So for this one, the Fibonacci sequence, it's kind of a special type of sequence, which would be neither. All right, let's take a look at one more. So for this one, we're going to have 2, 6, 18, and then the next number would be 54, and so on. Determine whether this one is arithmetic, geometric, or neither. Again, arithmetic is find the next one by adding or subtracting. Geometric, find the next one by multiplying or dividing. And enter your answer when you think you know which one it is. Yep, probably you guessed it. It's the only one that's left, geometric. That means I can find the next number by multiplying. In this case, it would be multiplying by 3. So times 3 would be my common ratio on this one. So hopefully we have a good sense of how to do problems like this now. You should be ready to start the big ideas math for section 6.6, and let me know if you have any questions.